Hey 6th graders, this is lesson 8-6. We are still learning about data, but today we are talking about a new type of data point called the median. And the median is a very simple thing to figure out. It is just the middle data point, okay? So if I gave you guys a list of data, if we have 8, 9, 10, 11, and 12, if these were my data points, 10 would be my median because it's in the middle of the data. Now the trick here is that your data has to be in order from least to greatest, or it could be from greatest to least, either way, but they have to be in order. Like if these numbers were all scrambled, you first have to put them in order and then it's the one in the middle. So the median is just your middle data point. The other slightly tricky thing is if I added, let's say, another data point on here. Let's say I had 8, 9, 10, 11, 12, and 13. Then what would be the middle number? Well, it looks like maybe there's not a median because there's no middle number. It's 10 and 11. Well, the rule is when you're determining the median, if you have an even number of data points, then you must find the average or the mean of the middle two. Now in this one, when they're right next to each other, it's really easy. You get 10.5 or 10.5 because that's in the very middle of 10 and 11. But it gets trickier if their numbers are more spread apart. Like if your middle two numbers, if they were in order, were like 258 and 790, something like that, you would have to add those two numbers together and then divide by 2 to find the very middle. So just giving you that heads up, that's a little bit of background knowledge before we start this lesson today. So it says the median is a single number that summarizes the center of a set of numerical data. The median is the middle number or the mean of the two middle numbers when the data are arranged from least to greatest or greatest to least. So pretty much everything I said here was what we did over here. So number 1, the numbers at the right are ordered from least to greatest. So these are already in order. Find the median. 22, not hard. That's right in the middle. I love that. No calculations, just looking at it. Number 2 says the dot plot at the right displays 10 data values. Find the median of the data. Well, how do you find the median when they're on a dot plot? Well, one thing you could do is you could write all of these in order. You could write down with your pencil 45, 46, 47, 47, 47, 48, 49, 49, 50, 50, and write them all in a big long list, just like they are in number 1, and then find the middle. Or what I think is easier is to take your numbers and count how many total there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 total. And so what we're going to be doing is finding, well, what's the very middle of 10? Okay, well, the very middle of 10 would be between the 5th and the 6th one. So if there's 10 data points, 1, 2, 3, 4, 5, then your 6th data point is right here. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are your 10 data points. And you're trying to figure out, well, what's my middle? Well, if I have 5 on the left and 5 on the right, it's in between these two. So what is the middle of 47 and 48? It's 47 and a half. Okay? Now, if that was crazy, then I would just say list them all like I said in the first place. You could say 45, 46, and then there's 47, 47, 47, 48, 49, 49 again, 50, and 50 again. And then you could say, well, what's in the middle? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There is no middle because it's an even number, so it would be the average of these two, 47 and 48. The middle of that is 47 and a half. Number 3. Some animals can move very fast for short distances. The table at the right shows the top speeds at which some animals can move. Find the median speed. All right, so here's a bunch of these. Some people might be tempted to do this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Here's the middle. What's the middle of 50 and 25? No, don't do it like that. You have to put them in order first. So my lowest one is 12. 25, 30, 32, 35, 40, 42, and finally 50. Now that these are in order, I can finally find the median or the middle. So they're kind of tied like this. We've got 12 and 50, 25 and 42, 30 and 40, 32 and 35. Since this is even, these are the two in the middle. So what's the very middle of 32 and 35? If you're not sure, then add them together and find the mean. So you're going to take 32 plus 35, which is 67, and then, since there's two data points, take 67 and divide it by 2. 2 goes into 6 3 times. 2 times 3 is 6. Subtract, we get 0. Bring down our 7. 2 goes into 7 3 times. 3 times 2 is 6. Subtract, and we get 1. So we end up with 33 and a half. You could put 33 and a half. You could put 33.5. And that's your median, the very middle data point. Okay, so then it tells us a set of data may have an odd number of values or an even number of values, which is kind of what we set up here when we started the lesson. You can have an odd number, then you just circle the one in the middle, or if you have an even number, you have to find the mean of the two in the middle. So, number 4 says using words describe the median of a numerical set of the data when there are an odd number of values in the set. Okay, so if it's odd, that's like the first example. So put them in order. From least to greatest. And that's step 1. And then after you put them in order, you find the middle number. Okay, and your very middle number is your median. And this is if you have an odd number of data points. Well, what if you have an even number of data points? Using words describe the median of a numerical set of data when there are an even number of values in the set. So still, you have to put them in order from least to greatest. And then, instead of just simply finding the middle, then you find the mean, or the average, of the middle two numbers. Because if there's an even number, then you're going to have two that are in the middle instead of just the middle number. So your median is the one in the middle, but if there's two in the middle, you have to find the mean of the two in the middle. All right, next page. Puzzled Penguin. Dear math students, I was asked to find the median of the set of data of the numbers of the right. By counting, I discovered that there are 3 numbers to the left of number 1 and 3 numbers to the right of number 1. So I decided the median is 1 because it's the middle number. Can you tell me what I did wrong? Oh, please tell me you guys can see what he forgot to do. He didn't put them in order first. Right? So you have to list them either greatest to least or least to greatest. So if you do that, you would have 1, 4, 5, 6, 7, 8, 9. And then 3 on the left, 3 on the right. The median is 6. All right. Next Puzzled Penguin says, Dear math students, I wrote the two sets of numbers shown at the right to help a friend understand how to find the median of a set of numbers. So he has this set, 205, 142, and 110, and he also has this set, 56 and 40. So I explained that the median of the top set of numbers was 142 because 142 was the number in the middle. You guys think this is the median? He's right. For the top set. Because they are in order, greatest to least. We usually do least to greatest, but this is greatest to least, and that is the middle number. So he's actually right for the top one. Okay? Now, for the bottom one, it says, then I explained that the bottom set of numbers had no median because there was no number in the middle. Is that true, you guys? There's nothing in the middle here? Well, there is something in the middle. You just have to find the average of those two. So, for the bottom set, he must find the mean of 56 and 40. Right, so if you add 56 and 40, you get 96. And then because there's two data points, to find the mean, you take that sum, 96, and you divide it by 2. 2 times 8. 2 times 4 is 8. Subtract and you get 1. Bring down your 6. 2 times 8 is 16. So the median of the bottom set is 48. So the bottom set, the median is right there, and it's 48. Okay? So if you have an odd set of numbers, then your median is one of your numbers. If you have an even set of numbers, your median is usually not one of your numbers that was listed in the beginning. It's usually a number that's right in between them. All right. So now we're going to be looking at two different ways to look at data at the same time. We're going to look at the mean and the median. So we're going to compare the dot plots. Plot A has a line of symmetry. If you guys remember that symmetry is when something looks the same on both sides. That's why it says symmetric over here. Says the data in plot A are symmetric because the shape of the data on one side of the line of symmetry is the same as the shape of the data on the other side of the line. So right here, you can see they have a line of symmetry, a little arrow. That's because both shapes look the same on both sides of that arrow. Then it says that plot B has the same number of data values as plot A, so they have the same number of circles, but when compared to plot A, some values in plot B have been shifted to the left. So what they did is these yellow ones in A, they took those away. Notice how those are missing on B, and they moved those 3 yellow ones right here. So B is no longer symmetric like A was. So it says calculate the mean and the median of plot A. So if I want to find the mean, that's the average, well, just by looking at it, that's pretty easy because this reminds me of our balance point activity. 15, I can tell visually that this is balanced right on top of that 15. So the mean is 15. Now the question is, what is the median of this one? What is in the very middle? Well, how many points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 10 total, I want the middle between the 5th and the 6th one. So we got 1, 2, 3, 4, 5 on the left. And then 1, 2, 3, 4, 5 on the right. Okay, so in the very middle is still 15. And again, if that's confusing for you guys to try to find the median just by looking, then I would recommend writing your values down. So you could have 13, 14, I was supposed to have another 14 in there. 13, 14, 14. And then there's 4 15s. So 15, 15, 15, 15. And then there's 2 16s. And then there is a 17. So how do you find the median? Find the one in the middle. So we have 1, 2, 3, 4, 5 on the left. 1, 2, 3, 4, 5 on the right. So the median is right there in the middle. What's in the middle of 15 and 15? 15. It's just itself, right? What's the average or the mean of 15? 15 plus 15 is 30. Divided by 2, you get 15. So the median is 15. All right. Then it says plot A is a symmetric dot plot. How is the line of symmetry related to the mean and the median of the data? We can just say the line of symmetry is the mean and the median. So that's really cool. When you ever have a set of data that looks like it's symmetric, like the same shape on both sides of the line of symmetry, then that line of symmetry is your mean and it's your median every single time. Number 10, using words predict how the mean and the median of plot B may be different than the mean and the median of plot A. So I think that the mean and the median are going to go down. I'm just going to say that. I think they will both go down. That's my prediction. Now, why do I think that? Because I think that they're probably going to go down because 3 values were higher on plot A, and then on plot B, those 3 values are missing, and now all of them are listed lower. So I think that's going to make all of our answers just decrease. They're going to go to the left or go down. Calculate the mean and the median of plot B. Was your prediction you made in exercise 10 correct? Well, now we get to find out if we were right or wrong. So I'm going to find the mean. The mean, I get to add 12 plus 13 plus 13 plus 14 plus 14 plus 14 plus 15 plus 15 plus 15 plus 15. Oh my gosh, that's a lot of numbers that I get to add. Okay, so if I get to find the mean, let's see, 15 and 15 is 30. Another 15 and 15 is 30. So if I put those together, I get 60. I'm just doing some math in my head here, so I get 60. 14 and 14 is 28. I know that 13 and 13 is 26. And I know 12 and 14 is another 26. So this is getting a little bit easier. So now I can just add 26 and 26 and 28 and 60 and see what that equals. 8 plus 6 is 14. 6 more is 20. 6 plus 2 more is 8. 9, 10, 11, 12, 13, 14. So we get 140 for our sum for my mean. But remember, when you do the mean, you get to do your sum and divide it by how many data points there were, which I believe was 10. 4 plus 3 is 7, 2 more is 9, 1 more is 10. So 140 divided by 10 equals 14. So my mean is 14. Now my median is the middle number. Now I'm going to use what I wrote down for my mean because that was listing all of my points in plot B. So because there were 10 of them, I'm going to find my middle value. So I'm going to go like this and just scoot towards the center. And I end up with 2 middle values that are 14 and 14. Usually when you have an even set of data, you have to take the mean of your 2 middle values. But 14 plus 14 is 28. Divided by those 2 values is just 14. So when both your values are the same, the median is that number, which is 14. So in this case, did they go down? Yes. The mean in plot A was 15. The mean in plot B was 14. The median in plot A was 15. The median in plot B was 14. Okay, so it said, was your prediction correct? Yes, I said they will both go down, and they did. They both moved from 15 to 14. Why do you think the shift of dots to the left, as is shown in plot B, decreased the mean and the median of plot A? So like, why was I thinking that when they moved to the left that would make those values go down? I think just simply because I think the easiest way to say that probably would be that the values all decrease. So It just kind of makes sense that if your values of your data decrease, then the values of how you analyze your data are going to decrease as well. So I'm just going to say the values all decrease. Okay, so we're going to look at some more comparisons now. We've got compare these two dot plots. Two data values in symmetric plot A have been shifted to the right. Okay, so it was symmetric in plot A. So the mean and median are 15. Remember, your line of symmetry is your answer for your mean and your median. But those two yellow ones are missing in plot C. They're gone now, and they moved them right here. How do you think that will affect the data? That's question 14. Make a prediction. Well, I think if they were right here and they both move more towards the right, I think they're probably going to make them increase. But let's figure out. Let's go ahead and do that because we're supposed to calculate it right here. So our mean and our median. All right. So our mean, we've got 13 and 14 and another 14. 3 groups of 15. 16, 17, 18, 19. Okay, so I'm going to do my median first, actually, because these are already in order. And I have 10 data points. 1, 2, 3, 4, 5. Okay, so my median is sharing the mean of 15 and 15, which is just simply 15. But what about my mean? I need to add all these up. That's going to be a big job, but I can do it. I'm going to add up my left half and my right half and see if that is a little bit simpler for me. So 13, 14, 14, 15, and 15. And then on my right half, I'll do 15, 16, 17, 18, 19. The reason I'm doing this is because that's so many numbers to add. I'm just breaking it up so it's a little bit easier. 5 and 5 is 10. 4 and 4 is 8. 10 plus 8 is 18. 3 more is 21. 21. 2, 3, 4, 5, 6, 7. So we get 71. On this side, we have, let's see, 9 and 8 is 17. 7 more is 24. 6 more is 30. 5 more is 35. 3, 4, 5, 6, 7, 8. So now I get to add both these together, 71 and 85. And I get 156. Now, that was a lot of work to add all these numbers together. I got 156, but I need to remember that when I find the mean, now I need to divide it by how many data points there are. And so there's 10 data points, so 156 divided by 10 is simply, when you divide by 10, you just take your decimal point and you move it to the left when you divide. So I get 15.6 for my mean. All right. So how did this affect my data? I thought they were both going to go up, but they didn't. The median actually stayed the same. I'm going to say the median stayed the same. And then the median, not the median, but the mean, which is the 15.6, it went up. It was 15, now it's 15.6. So I'm going to say, but the mean increased. So the next question is, why? Why does a shift to the right increase the mean? Why did our average go up? Okay, I'm going to say the data values increased. So that means the sum increased. So that means the mean did too. It's all connected. Okay, so if your values increase, your mean is going to increase as well. Not always your median. We found out right here your median doesn't always increase, but your mean does. If your numbers go up, your mean is going to go up as well. Okay, so we have another picture. It was symmetrical in plot A. Line of symmetry is right here at 15, so our mean and median are both 15. But now they changed those two yellow dots. They took those two yellow dots off. They're missing from plot D, and they moved them over here to the left. So what do we think is going to happen? Well, I predict it's going to be lower because it moved to the left where there's lower numbers. That's my prediction, but we'll have to figure it out. So the mean and the median. I'm going to add my numbers up. So we have 11, 12, 13, 14, 15, 15, 15, 16, 16, and a 17. Okay, I'm going to do my median first because I can tell just by looking. So I've got to find the very center number, 15 and 15, which is just, again, 15. Now if I want to find my mean, I need to add these all up and then divide by 10 because there's 10 data points. Well, I don't want to add them up, but I have to. So here we go. I'm going to do my strategy from last time. I'll do half and half, just a little bit less work for me. You might not think so. Maybe you would prefer to just do a long line of numbers, but for me that gets a little confusing. Okay, so first I have 1, 2, 3, 4, 5. So let's see. 5 plus 4 is 9, plus 1 more is 10, plus 2 more is 12, plus 3 more is 15. 10, 20, 30, 40, 50, 60. So we get 65. And then we get on this side, 5 plus 5 is 10, 6 plus 6 is 12. So 10 plus 12 is 22, plus 7 more is 29. 20, 30, 40, 50, 60, 70, 79. Okay, so now I have to combine those because I split it up to make it easier. 65 and 79. And we get 144. So that is my sum. All of these numbers added together, all of these data points when you add them, is 144. So if you want to find the mean, you need to divide by how many data points you had. So since we had 10 data points, we get to do 144 divided by 10, which is just 14.4. Remember up here on this set, you just move your decimal point one place to the left when you divide by 10. So 144 becomes 14.4. So they ask us the same questions. How did the shift of dots to the left affect the mean and the median? Well, this time, instead of shifting them to the right, they shifted them to the left. So I'm going to say our median stayed the same, just like before. But the mean decreased. And why did the mean decrease? Why did they do that? Just like before on this one, we said the data values increased, so that means their sum increased, so their mean did too. This is the opposite of that. The data values decreased instead of increased. They went down. So the sum decreased. So the mean did too. Everything decreased. So everything in your mean has to go down when all your numbers go down. All right, so we are going to compare some more. And what we've got here is it starts as, actually, you know what? I'm gonna make a decision here. I think you guys get the idea. We're gonna skip this page, okay? It's not that it's not important. Oh, it's just taking a lot of time and I don't want the video to be this long. Okay, and I'm crossing it off, but I still want to talk about it a little bit, okay? So on plot A, you've got a line of symmetry, which means mean and median are both that line of symmetry. They're both 15, but look at these yellow dots that they skipped, or not that they skipped, that they moved. They were right here on the left, and they moved them to the right. Now, without doing all the calculations, I'll tell you just from the teacher's answer book that the mean went to 16.1, it went up, and the median also went up. And if we do the ones down here, you'll notice that they took these 3 data points that were on the right and they moved them to the left. And so on this one, the teacher's answer book already did the work, and the mean changed to 13.9 and the median changed to 14. So basically the questions they're asking us here are, why did shifting the data from the left to the right make everything go up? And why did shifting the data from the right to the left make everything go down? Well, it's the same answers as before. If you shift your data to the right, everything's increasing. If you shift your data to the left, everything is decreasing. But how come on this page, our median stayed the same? That's because our middle data point was still in the middle, okay? But right here, our middle data point, it ended up moving. It increased, so our median went up, and our middle data point here, it decreased, so our median went down. So without doing all the calculations, that's just kind of a super fast summary of that page. Hopefully you guys appreciate that I did that instead of just making you watch a super long segment on the video again. Because there's still one more page in the book. That's another reason I wanted to keep moving on, because this lesson has a ton of pages. Okay, so this is our last page though, so we'll get through this. It says, estimates of the populations of 7 cities in Colorado are shown in the table at the right. The populations have been rounded to the nearest 1,000. Calculate the mean of the data. All right, well, I have a really easy way to do this. Since these all are rounded to the nearest 1,000, I don't have to actually add all those thousands. I can just add like this. So I'm going to just do 17, 18, 17, 66, 17, 16, and 17. I'm just going to add those numbers, and then I'll just put 3 zeros on the end, because it'll end up being the same thing. All right, so how many 7s do I have here? 1, 2, 3, 4. So 7 times 4 is 28, plus 6 more is 34, plus 6 more is 40, plus 8 more is 48. Now if I do my tens place, we have 6 plus 4 is 10, 11, 12, 13, 14, 15, 16. So we end up with 168. Now my total is 168. Remember, we're working in thousands, but how many data points are there? 1, 2, 3, 4, 5, 6, 7. So we need to divide this by 7, because when you find the mean, that's what we're doing. The mean is you have to divide by how many data points you have. 7 goes into 16 2 times. 2 times 7 is 14. Subtract and we get 2. Bring down our 8. 7 times 4 is 28. Subtract and we get 0. So 24 is our mean, but remember we're working in thousands, so it's 24,000 is our mean. Then find the median. Well, the median, remember, you must put all this data in order. Now I want to remind you, just like we did with our mean, I am not going to include all the zeros on there. I can just do that in my final answer. So I need to list this from least to greatest. So my least one is 16. Then I have 17, 17, 17, 17. So I'm going to write that 17, 17, 17, 17. So I did my 16, 17, 17, 17, 17. What's left? 18. Also 66. All right, so if I want to find the median, it's what's the middle number. So one way to find the middle is to go like this, so the beginning and the end, go one number in, and here we are at the middle. This was an odd number of data points. There were 7 data points, so the middle one was just one number all by itself, 17. And we can go ahead and put 3 zeros behind it because we were actually working in groups of 1,000. So 17,000 is the median. Now, the next question is really important because we're doing these weird calculations. The mean, that's the average. The median, that's the middle number. But like, who cares in real life? It actually does matter. Here's a time where it matters. It says, how could you summarize the populations of all 7 cities using only one number? Okay, so if you wanted to tell somebody, hey, there's a bunch of people living in all these different cities, and somebody goes, oh, like how many people? Well, there's a couple ways you could describe it. You could say, well, there's 7 cities there, but about how many people that is in each one, you could tell them the mean, or you could tell them the median. Which one would you pick in this situation? It says, would you choose the mean, or would you choose the median? And give a reason. Well, here's what I'm thinking, you guys. I would say a lot of times I would pick the mean. It's the average of all the cities together and say, oh, well, there's about 24,000 people in all these cities. But really, when I look at that data, I go, 17, 18, 17, 66, 17, 16, 17. Man, a lot of them are really close to 17,000. It's just that 66 one that's really, really big. So in this case, I would not tell somebody, well, there's about 24,000 people living in each city. Because that's crazy. That's not true. That's way more than what a lot of them have. The only reason it's 24, why it's so high, is because that 66,000 is so much bigger than the other ones. So in this case, not always, in fact, usually I do go with the mean, but in this case, I would use the median. Because it better describes the data. And I would not use the mean because the mean is much higher than most of the data. So that's just me. I think for this case, the median is 17,000. Most of these numbers are close to 17,000. 17, 18, 17, 17, 16, 17. And then you got your 66, which is crazy. But if you went with your mean, 24,000, that's not really close to any of them. So in this case, I would use the median if I was going to tell somebody just one data point. Hey, most of these cities, yeah, they're close to 17,000 people. That would make sense. All right, our last problem set. Rachel has a new part-time summer job. She works 3 days per week. Her earnings for the first 2 weeks are shown in the table at the right. It says calculate the mean earnings, remember that's the average, per day for each week. Okay, so for each week. For week 1, we need to add these together and then divide by 3 because there's 3 data points. We have 20 plus 40 plus 30 is $90. Divided by 3 weeks, an average or a mean of $30. For week 2, we've got 40 plus 10 plus 40. Hey, that's $90 again. Divided by 3 weeks equals $30 on average for the mean for each week. Okay, what about the median? Well, if I want to find the median, I have to list them from least to greatest and then find the middle. So for week 1, the least is, it goes 20, then 30, then 40. 20, 30, 40. What is the middle number is $30. What is the median for week 2? 10, 40, 40. 10, 40, 40. What's the middle is 40. Okay, so we found the mean, we found the median. The mean was the same for both weeks. The median was $30 for 1 week and $40 for the other week. So the question is, suppose Rachel wants to summarize her earnings for the first 2 weeks using only one number. Should Rachel choose the mean or the median to summarize her earnings? Give a reason to support your answer. So basically, if she was going to tell somebody, hey, I have this job for the summer, and she's worked for 2 different weeks, but here's like the 3 days she worked in week 1, here's my 3 days that are worked in week 2. She could give them all that information, but that's kind of overwhelming. It would be easier to tell somebody, hey, I worked for 2 weeks and here's about how much money I've been making. What number would you pick? Would you pick her mean, or would you pick her median? For me this time, I would pick her mean, because it was the same both weeks. So like on week 1 and week 2, she could say, oh, I'm making about $30 a week, and that would be true. If she tried to use her median, it would be more confusing, because 1 week she made a median of 30 and 1 week she made a median of 40. So if she wanted to find the mean of her medians, she could say 35. But I think in this case, it would make the most sense just to say, hey, the mean, the average that I've been earning is about $30 per week. So 6th graders, that is the end of our lesson. Basically, we're looking at 2 different types of analyzing data, mean and median. Mean is when you're finding the average. Median is when you're finding the middle number of your data. It's just depending on what situation you have, which one makes more sense, if you want to find the mean or if you want to find the median. Sometimes it's important to find both and then figure out kind of what information you're trying to get and which data point would be more important for you. So we are going to continue learning about more ways to analyze data during our next few lessons. All right, have a good day.